All right, today's lesson 17, drawing the coordinate plane and points on the plane. So this says draw all necessary components of the coordinate plane on this blank 20 by 20 grid provided below, placing the origin at the center of the grid and letting each grid line represent one unit. That's what that looks like. Each one is one unit. I've labeled my fives, positive 5 and negative 5 for both the x and the y axis. And it goes to 10 on each side of the grid. Example 1 says, drawing using the coordinate plane uses a 1-to-1 scale. Locate and label each one of the points, 3, 2. That would be that one. 8, 4. That one right there. Negative 3, 8. That one right there. Negative 2, negative 9. Down there. 0, 6. Up there. Negative 1, negative 2. Right there. And 10, negative 2, right there. The second example says drawing the coordinate plane using an increased number scale for one axis. So draw a coordinate plane on the grid below and then locate and label the following points. So I have those points there. You'll notice that for the x-axis, each one represents 1, because if we look at the top numbers, right, I have a -4, a -3, a 1, a 6, and a 9. I don't have anything above 10, so I can still use 1s for those. But if you look at the second set of numbers, right, in that coordinate point, remember it's x, y. So the second one, the y's, I have a 20, a 35, a -35, a 10, and a -40. So the biggest number that I'm going to need is to get to a -40. Or excuse me, the smallest number that I'm going to need is to get to a -40, and the biggest number that I'm going to need to get to is a 35. So I went ahead and made each one of those lines up and down on the y-axis worth 5, and you'll notice they're also in increments of 5, right? 20, 35, -35, 10, and -40. So all of them will be on a line somewhere of 5s. So my first one, -420. My second one, -335. My third one, 1, -35. 6, 10. And my last one, 9, -40. Third example here is using a decreased number scale for one axis. So you'll notice the same thing with the exception that I have for the x values, I have a 0.1, a 0.5, a -0.7, a -0.4, and a 0.8. So not even one whole. So I can do the same thing, but instead of going by 1s, I go by 0.1s for the x-axis. The y-axis, you'll notice I have a 4, 7, -5, 3, and 1. So I can go ahead and go with, excuse me, with 1 for each axis there and just make it easy. So my first one, 0.1, 4, 0.5, 7, -0.7, -5, -0.4, 3, 0.8, 1. And this example here says we're going to use different number scales for both axes. So determine a scale for the x-axis that will allow all x coordinates to be shown on your grid. Well, what we want to do is we want to find the biggest and the smallest values for my x, and that'll be my x-axis scale. So from what I can see, these numbers down below, I have a -14, a -4, a 6, a 14, a 0, and a -8. So my biggest is a +14, and my smallest is a -14. Next, determine the scale for the y-axis that will allow all y coordinates to be shown on your grid. Looking at the y coordinates, or that second number in each of those series, I have a 2, a -0.5, a -3.5, a 2.5, a 3.5, and a -4. Right, so we want to find our biggest and smallest values for those. My biggest value is a 3.5, and my smallest value is a -4. There should be a little negative symbol here. Right. And draw and label the coordinate plane, then locate and label each one of the sets of the points. So there's my coordinate plane, right? I'm going by 0.5s on the y-axis, right? You'll notice the second line is where the 1 and -1 are respectively, and I'm going by 2s on the x-axis to fill in those 14s. First point is -14, 2. Then I've got a -4, -0.5. I have a 6, -3.5. I have a 14, 2.5, a 0, 3.5, and my last one is a -8, -4. We're off to problem set.